Hello everyone, welcome to Ladboy Coding. Today we're going to solve problem 430, flatten a multi-level doubly linked list. So given this structure, we need to traverse the linked list level by level, and then return the following output. So from 1 to 2, 3, then 7, 8, 9, 8, 11, 12, then 9, 10, then 4, 5, 6. So we need to use a stack to do a depth first search. Let's first demonstrate our algorithm. So first, we need to put the first node on the stack, and we are also creating a dummy node, 0. Then we get the element from a stack and then connect it with dummy node. We also put the next element of the current list to the stack. So the next element is 2, and we get 2. Then we put 3, we get 3. Then if it has a children, we need to put the next element first, 4, then put its children, 7. So we can use the stack's last in, first out property to do a depth first search. We get 7. And then 7's next element. Then 7's next element is 8. We get 8. Okay, 8 has a children, so we need to append 9 first, and then append its children, 11. So here we get a 11. Then we need to put the next node of 11, which is 12. We get 12. Then we get 9. Then we need to put the next element of 9, which is 10. We get 10. At last, we get 4. And we append 5 to the stack. Then we get 5, append 6 on the stack, and then we get 6. Eventually the stack is empty, and we get a flattened structure. Okay, so yes, 1, 2, 3, 1, 2, 3, 7, 8, 11, 7, 8, 11, 12, 9, 10, 4, 5, 6, 12, 9, 10, 4, 5, 6. So this is our algorithm. Let's code it. If the head is none, we just return the head. Otherwise, we need to create a dummy node. And then we put the first node on the stack. While stack is not empty, we need to do the following operation. So let's get the current node. And then we need to create the doubly linked list structure. Let's create a new node. And we set the next pointer to the new node and the pref pointer to the dummy node. So it is doubly linked. Then we increment our dummy pointer. Then we need to append either the next node or its children node. So if it has a child, then we append it. Otherwise, we append next node. So here we need to append the child, then append the next node. In the end, we just need to return dummy.next. Result dot next. Let's run it. Oops, never mind. We need to append the node, not a list. So if it is not none, we do this. Oh, and by the way, we need to unset the pref pointer to make it a valid doubly linked list. And then it's wrong answer. What happened? So 1, 2, 3, 1, 2, 3. Okay, 1, 2, 3, 7, 8, 9, 10. So we need to append the next node, then the child node. Okay, let's submit it. That's it. So let's analyze our time space complexity. So the time complexity is indeed linear with respect to how many nodes in this linked list. And the space complexity is also linear because we create a node. That's what we return. Okay, thank you very much. If my solution helped you, please feel free to leave a comment. Bye-bye.